Well, guys, this is our last AB lesson. Can you believe it? I'm a little shook right now, but here we go for the last time. All right. Example 1. Suppose the rate of change of y with respect to t is proportional to the current value of y. Now let's translate that to a math sentence. Suppose the rate of change of y with respect to time, that would be dy dt, is proportional to the current value of y. Remember proportionality, you have that proportionality constant, which is k, so you have k times y. Now remember, if I ask you to solve that differential equation, then your variables are y and t. So you want to get an equation for y in terms of t. You have to look at that k as a constant. So from what we did yesterday, stop the video, see if you can get it. What would you do? Well, you would separate. So you have dy over y is equal to k dt. I'm going to integrate and integrate. I would get natural log of the absolute value of y is equal to kt plus c. And from our little fun time yesterday, we're going to do this e to the step and e to the step. I get absolute value of y. You do that fun little multiplication. And then when you replace this with big C is when you can drop the absolute value, and so you get that equation. So here's the good news. Anytime you see this differential equation, every solution to that exact differential equation can be written of this form. You can go straight there. You do not have to show all this, okay? And so when that happens, C is the initial value. If K is positive, you have exponential growth. And if K is negative, you have exponential decay. Now let me reiterate, it has to be that exact same form. If there's any plus 2 or times 100 or anything else in there, you're going to have to go through the steps. But let's look at example 2. At any time t, in days, the rate of growth of bacteria is given by y prime, or in other words, dy dt, is equal to k times y, where k is a constant and y is the number of bacteria present. So in other words, you already know the equation and you don't have to go through the whole solving the differential equation, because again, you have dy dt is equal to k times y, so you know if I went through it, it would look like this. So it says the initial population is 1,000 and the population triples during the first 5 days. Well, what do we know? Let's set this up and have good work here. Well, I know without work, I'm going to go straight to this equation. I don't have to show it. I know it. What else do I know? Well, if the initial population is 1,000, that means when t equals 0, I better get 1,000 for y. So wouldn't that be true that we already know that C is going to be 1,000? Because if I put in 0 for T, do I get 1,000 for the population? And I do. Now the other information they give you is for finding the K value. It said that the population triples during the first 5 days. Or in other words, notice that T was in days. If I put in 5 for K, I would triple the population. So if it's 0, it's 1,000. Tripling would mean I would be at 3,000. So let's do the algebra. I, of course, to solve for K, I would divide by 1,000. And I'm going to simplify because that would be silly not to. I have 3 equals e to the 5k. Think about taking the natural log of both sides. So I have the natural log, natural log. I can bring that 5k to the front. So I would have natural log of 3 is equal to 5k natural log of e. Of course, the natural log of e goes away. So I get k to be the natural log of 3 over 5. So what's my equation? My equation is y equals 1,000 e to the natural log of 3 over 5 times t. And that's the exact answer. Now, I want to be very clear. There's several things you need to make sure if you are solving. When you solve, you need to do a storing step because that k value, when I do natural log of 3 divided by 5, okay, first of all, I check to see if it's positive because if it's growing, it better be. So it is. I'm going to store that. Again, you can store in any letter, but I'll pick K just so we're not confused. I now have that in K. And I want to be very clear of what your equation is. You either write ln of 3 over 5. Again, you can write it to 3 decimal places, but on your paper, but you make sure that you use the whole value in the equation when you're using it. So again, if you wrote 1,000 e to 3 decimal places, I guess that would be 0.22 t. Would you get credit for that? Yes. But if you're using 0.22 versus the whole value of k, your answer is going to be way, way off. So make sure that you're not rounding. So let's look at part B. Part B says, I think I can fit it in right here, what is the population of bacteria in 12 days? Well, now that you have your equation, wouldn't you just do y equals 1,000 e to the 0.22 times 12, but again, I have that stored into K. And remember, if you've already established and have on your paper what K is, I technically could write this and be good. Okay, so there's just a lot of different things you could write to get full credit. So you kind of figure out the one you like. Some people would write that. I mean, it's just dependent on what you want to do. But the key is getting the correct answer. I have that into K, so I'm going to put 1,000 e to the, I've got it stored into K, so it's really 12 times K, so 12 alpha K, and I hit enter, and there's my bacteria. Now notice, y'all, if it doesn't say round, even though you think, well, can you have part of a bacteria? If they don't tell you to round to the nearest whole, then don't do it. And I just want to show you the difference. If I use 0.22 and use that rounded value, e to the 0.22 times 12, look how different my answer is. So that's the importance of not getting that rounded, using a rounded value. All right, last one. Part C says, at what time in days will the population have increased by a factor of 6? So in other words, okay, at what time in days? So obviously I'm solving for t. So I have 1,000 e to the kt. Remember, I know what k is. I can write it that way because I've established what it is. What am I trying to figure out? I'm trying to figure out when that is equal to increased by a factor of 6. Well, what would that be? Well, that would be 6,000, correct? Now, you have your choice. And how you want to do this, I'm going to do it two ways, and you can pick your fancy. The first way is to solve for t just kind of like I solved for k over here. So some of you algebraic people are going to be like, oh, I'd just rather do algebra. You're going to divide by the 1,000. So you have 6 equals e to the kt. Remembering I know what k is. I'm going to take the natural log of both sides. So kt would be equal to the natural log of 6. So t is going to be the natural log of 6 divided by k. Remember, I have that k stored rather. So I just hit the natural log of 6 divided by k. And there we go. I get 8.155 days. For you people that are like, I like graphically better, anytime you have an equation and what it needs to equal, you can put your equation in y1. So you have e to the, I can put k in there in my variable, that's fine. I can put 6,000 in y2. Just you graphical people, again, what you have on your work is just the equation and then the answer, and that's okay. You just have to be good at finding your window. I don't want you to be fumbling around with that, but you look at the number of days and you go, okay, it's, you know, triples the first 5 days. It's trying to get to 6,000, so you kind of estimate that. If it's multiple choice, you kind of look at the answers and kind of help. So you think, oh, maybe like, you know, 15 days or so. The y's you shouldn't have to guess at, because you're trying to get to 6,000, so let me just go to 6,500. As long as it's over 66,000, you're good. You're going to see y1 or y2 and y2, both of them, and you're going to do just a second calc intersect. So you're just going to go second calc intersect. If you don't see your cursor, you can hit the up or down arrow key, but I'll bring it there. And notice we got 8.155 with rounding, just like we did. So you can pick the day, I was thinking days. You can pick the way that you would like. Let me say one other thing, because I would hate to not mention it, and then it show up, and then you'd be like, wish you would have told me that. Right here, again, I just kind of store for k. I just leave it that way. I don't do this change. But if this were multiple choice and you were finding that equation and that wasn't there, again, you see logs. I want to just show you one, just to be careful of how else they could write that. And you might like this. So if you prefer to clean it up this way, you can. I would have 1,000. By these log properties, remember how if I do a power to a power, I multiply? So I technically could write that equation like this. Do you agree with that? Because again, if I multiply all these powers together, I would have natural log of 3, that t is really on top, over 5, and that's the same thing. Well, what is e natural log of 3? Well, remember, e and ln are inverses of each other, so they, in a sense, cancel each other out. So this equation is the same as 1,000 if the e and the ln cancel, 3 to the t over 5. So if you see that on my paper, or if you like to do it that way, you certainly can. It doesn't matter. You store. If you're using k, if you like to clean it up, then the numbers look a little easier. So you can choose kind of the way you like. Okay? All right. Oh my gosh. Our last example. Here we go. A cup of coffee is 180 degrees, is placed in a table at a room with 68 degrees Fahrenheit. The differential equation for the temperature is that. Okay. After 10 minutes, what is the temperature of the coffee? So what do I have to do? Well, in this one, is my differential equation exactly like dy dt equals k times y? No, there's more stuff in it. So what am I forced to do? I am forced to do it. I have to go through the solving the differential equation. So I'm going to take this differential equation and do my steps. What are my steps? Separate the variables. So dy over y minus 68, those are kind of connected, is equal to negative 0.11 dt. After that, I integrate and integrate. I get natural log of the absolute value of this is equal to negative 0.11 t plus c. I'm going to do my e to the and e to the. And friends, at this point, if you can go, look, I get it. I don't have to rewrite that. I know I can drop the absolute value when I would do c e to the negative 0.11 t. They're perfectly fine with that. So I didn't show that step. But I think we've done it so many times, you got it. And then I'm going to bring that 68 over. So I have 68 plus c e to the negative 0.11 t. Now that's my general solution. It told me, of course, that the coffee at time, if it was 180 degrees, so I can plug in 0 for t, and I better get out 180. And so what would C be? Well, that's going to be whatever 180 minus 68 is. So that is 112. So my equation, we have y equals 68 plus 112 e to the negative 0.11 t. That's my y equals. Now the question really for letter A, that's not what it asked. It didn't ask me to solve the differential equation. It said after 10 minutes, what is the temperature of the coffee? And so you would have to, and you have on your paper that T is in minutes, so you would kind of have to know that. So T in minutes. Okay. So if I put in, so basically to get the answer to that is I need to do y of 10. And again, this is a calculator problem. So I'm going to do 68 plus 112 e to the 0.11 times 10. And I certainly am going to do that on the calculator. I'm going to go ahead and put my equation in y1 because I have part A, B, and C, so my guess is I'm going to use this equation several times. So let me go ahead and just get it in there. 68 plus 112 e to the, what was it, negative 0.11 x. There we go. So once I have that in there on the calculator, I can just hit alpha, evaluate y1 at 10, and there you go. It's always baffles me when, you know, y'all look at your answer and make sure that your answer makes sense. I've had people that it's talking about coffee being put into a room at 68 degrees. So obviously it's cooling off, and they give me an answer greater than 180. And I'm like, yeah, that doesn't even make sense. So your answer, think about logically what your answer should be before you get the actual value. Remember as well, remember when it's temperature, you cannot just put degrees. You either put degrees Fahrenheit or degrees Celsius. So this one was Celsius. This one was Fahrenheit. It's right in front of me. And so you put that. All right, part B. I'm going to move my calculator over here so I can write part B. Approximately how long does it take the temperature of the coffee to drop to 75? Okay, what equation are you solving? 75 equals your equation, right? And kind of same song, second verse. You algebraic people, do the algebra. You graphical people, do it graphically. And you can do it, you know, get it either way. I'm going to do it algebraically. It doesn't matter to me. But of course, you're going to subtract the 68 and divide by 112. So 75 minus 68, that's 7. 7 over, so I have 7 over 112 is equal to e to the negative 0.11 t. Again, with taking the natural log of both sides, I would get that the natural log of 7 over 112 is equal to negative 0.11 t. So my last step is, of course, to divide that right there. So I have natural log of, I think I'm okay with, since it's just one thing, I won't do the fraction. Okay, I know I don't need any more parentheses. So natural log of 7 over 112 divided by negative 0.11. And I get 25.205 minutes. And there you go. And again, if you like graphically, you have your equation in y1, you put 75 in y2, you think about your window, you overestimate, and let's say I left it at 15. I know my y-max is way too big because, again, 75, so I'll put 100. It's okay if you have to adjust your screen, your window. If you don't get it right the first time, that's okay. You kind of see the graph and you're like, oh, I mean, it would kind of be smart to put your temperature at 100, being that 180, since that's where it started. But you're seeing that it's coming down. You're like, oh, I need to see a little bit more over here. It's okay if you have to adjust it once or twice. I just don't want you to adjust it, 10 times and never get the window. So I'll even put 180 since that's the temperature at the beginning, so you see the whole graph. But as long as if you're doing it graphically, as long as you can get the window fairly quickly, then I'm good with that. If you're fumbling around a lot, then you need to do it algebraically. But again, you'll see that I get the exact same answer. So you can pick. So last one. Oh my gosh, I'm almost going to cry. Last one. It says, find the average temperature of the coffee during the first 10 minutes. Now, what have we talked about when we see the word average? We're going to circle or underline what's next to it. Find the average temperature. Do we have an equation for temperature? Well, yeah, that's what our y equals was. That was for the temperature of the coffee. Like in letter A, what was the temperature of the coffee after 10 minutes? That means in 10 minutes, what was the temperature? So you had an equation for temperature. So what's the formula for the average of something you have an equation for? It's integral over interval. Now you can write that down, but you certainly have to write a more specific one. So the integral is going to be the integral from 0 to 10 of our equation. I don't know why I'm putting the 68 at the end this time, but I did. Oh well, doesn't matter. Integral divided by interval. You have that in y1. You have your equation in y1. So very simply on the calculator, I'm going to math 9, 0 to 10. Now I want you to think about what the temperature is going to be, and I'm going to kind of say something funny, but you'd be surprised. Believe it or not, this is the answer I get a lot. People do that and they go 130, 1,000, 359 degrees. And I'm like, whew, that's hot coffee. People, the average temperature should be the average of your Y values. So if the coffee, I mean, think about that. That number is way too much. So you're like, oh my gosh, I forgot to do the divided by 10. So again, think about your answer. It should be logical. It's the average of the Y values of your Y equals. So the average temp in the first 10 minutes equals that. And so make sure you think about that and make sure you put a logical answer. And that, my friends, as they say, is all she wrote. All right. Good job, everybody.